I'm looking for groups of 3 instead of groups of 2. That's the only difference. So 108 is 27 times 4. 32 is 8 times 4. And 256 is 64 times 4. Now, of course, I could break this all down with giant factor trees. If you did that, that's okay. There's nothing wrong with that. If you need to see any one of these broken down as a factor tree, tell me now and I'll do that. Or is everybody okay with what I have done here? Everyone is okay? Nobody needs to see the proper factor trees here? Okay. The cubed root of 27 is what? 3. So out comes a 3. There was already a 2 there. So I have 6 cube root 4. The cube root of 8 is 2. So out comes a 2. There was a 1 there, so it stays as 2. 2 cube root 4. The cube root of 64 is 4. So out comes a 4. There was already a 3 there, so I had 12 cube root 4. 6 plus 2 plus 12 is 20 cube root 4. And there is where you're done. Now, some of you will try to tell me, you will go further, and you will say that that is 2. It is not. Why? Because it's a cube root. You have to be careful. All right? Is everybody good? Okay. I recorded all those right answers yesterday. On this page, here is all of the answers up to number 10. I am highlighting them as we speak, Gersa Hill. Now, obviously, do I need that negative 1 there? Or am I okay to write negative root 10? Yes. As a matter of fact, that is preferable. But this shows you what you actually did. You are just checking your work over. You are not trying to write down all the right answers because this is being recorded and you can do that on your own time later if you care. But if you don't have any answers to write down, that kind of means you don't really care. But that's beside the point. Is everybody good up to 10? Would anybody like to ask about anything up to 10? Amelia, which one? Number 6. Okay, number 6 is distribution. What number is in front of this root 10 that we don't write? It's a 1, right? And actually, I'm going to rewrite this whole thing. Could I rewrite this as 1 root 10 times 4 root 1 minus 5 root 2? Does everybody understand why this is the same as this? Does everybody understand that? Because 1 times root 10 is going to be root 10, isn't it? And what is the square root of 1? 1. 4 times 1 is still 4. Everybody cool? Now it's pretty easy because numbers go with numbers, 4, and radicands go with radicands, root 10, minus 1 times 5 is 5, 10 times 2 is 20. Then I simplify that, 4 times 5, to get 4 root 10 minus 10 root 5. Okay? Anything else up to 10? Emma? Number 7, certainly. Number 7 is the exact same thing. I could write that as 1 root 15, 1 root 3, plus 5 root 1. 1 times 1 is 1. 15 times 3 is the root of 45. Plus 1 times 5 is 5. 15 times 1 is 15. And then that one simplifies, right? Because that one is 9 times 5. Square root of 9 is 3. So I end up with 3 root 5 plus 5 root 15. Because 15 doesn't get any simpler because it's 3 times 5, no pairs. Addison. Yep. Simplify everything you see. That is 4 times 2, so that becomes 4 root 2. That is 9 times 7, so that becomes 12 root 7. That is 9 times 2, so that becomes minus 9 root 2. 4 minus 9 is negative 5 root 2, and root 7 has no partners, so it stays as 12 root 7. Now, ladies and gentlemen, I beg of you, 1 second, I beg of you, you must start seeing how everything is the same. You have to get out of that thing where you look at number 8 and you do it right, and then you look at number 9 and you think it's different. It's not, right? You are applying the exact same skills. Simplify everything. Add what is similar. Okay? Jazri. Oh, yes, it should be positive 3. Thank you. Anything else? And there is 11, 12, and 13. And as you just noticed, sometimes when you work fast, you make small mistakes like sign mistakes. If you have all the same numbers as me and a different sign, it's worth asking, because there's a chance I just screwed up the sign. Everybody cool? Gersa Hill.
Could you do number 11, please?
Certainly. We are going to break it down into 9 times 5. What's coming out of there? 3. What's already out front? So what does that become? 9 root 5. 96 is 16 times 6. What's coming out of there? 4. What's already out there? 2. So it becomes 8 root 6. Yes? Minus root 6. How many root 6s is that? 1. So I have 8 root 6s, and I'm taking away one of them. So what is the answer? 9 root 5 plus 7 root 6. Okay? Now, I do not know where your breakdowns with this are, right? My belief is that the problem is breaking down the radicals. Because I would like to believe that all of you can recognize that 7 root 2 plus 8 root 2 is 15 root 2s. Like, that shouldn't be part of the problem here, right? So the problem, in my mind, I guess, is breaking these down. Which means, what do you need to practice more? Breaking them down. How could you practice that? Get any number and factor it down. Any number. Is there questions in this book that you have not done? Yes. Are some of them on old math textbook pages that have the answers there? Yes. Is there a repository of all the information in the history of humankind available to you at your fingertips? Could you type in practice simplifying radicals into some sort of engine for searching? Would that yield results? Would those results have answers? Everybody understand? Okay. Anybody want to talk about 11 or 12 or 13, I mean? We're good? Everyone is ready to rock? All right. Please turn your pages over to, I want to say, page 38, which should have rational exponents with a fun little font that is called fontdiner.com sparkly. Yes. Did you guys get fontdiner.com sparkly? No? It didn't print?
Oh, wait, on this.
Yeah. Oh, it did good. Mm-hmm. Hmm? Yours says fractional? That's stupid. It's supposed to say rational because, of course, there is no such word as fractional. I used to type fractional because this used to be part of grade 9, even though we had never taught in grade 9 that the proper word for a fraction is rational number. So I guess I just cut and pasted. It should say rational, not fractional, because fractional is not a real word. But anyway, all right. Now, all of you who have a calculator, you all know how to enter on your calculator, 3 cubed, right? You hit the 3, which is, actually I'm not going to use 3 and 3 because that's stupid. Let's use 4 and 3. You all would hit 4, which is the base. Then you would hit a button that looks like either this, X with a little Y, Y with a little X, or the latest calculators, because people are so bad at math, actually show X with a blank. You would hit one of those buttons, then you would hit 3, then you would hit equals, right? All of you can make your calculator give you 64, yes? Every single one of you can do that if you have a calculator in front of you, yes? Okay. How do you think you would punch in that? What's the base? 9, so you would hit 9. Then is 1/2 an exponent? It is an exponent, yes? So we would hit the exponent button. Now I'm lazy, so I'm just going to draw the easiest exponent button for me to draw, which is that mountain sign, which is actually, in case any of you care, called a caret. Not like, what's up, Doc? It's this kind. And not like the carats on your diamond ring. It's a third kind of caret. It is spelt that way. Anyways, well, you would think it was carré, but in Francais, that accent is called a circonflexe, not a carré. I don't know what the heck. But it is called a circumflex. See how much stuff I know? It's stupid. And that was before the internet. Anyways. Now, all of you know that 1/2 is 0.5, right? So you could do 9 exponent 0.5. But if it was a fraction that you didn't know, you would have to go bracket 1 divided by 2 bracket. Okay? Most of you would. What did you do? Yeah. Oh, nice. Okay. But this is one of those situations where everyone's got a different calculator, but this will work for everybody. But when you do so, what do you get? When you punch that in your calculator, what answer do you get? 3. Right? Now do that with 27. 27 exponent button. Now this time you really have to do 1 divided by 3 because you're not going to sit there and go 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, right? Of course, you get 3 again. Now do it with 625. And that, of course, would be 0.25 or 1 divided by 4. And you get 5. Now, you should be able to put together already in your head, if you don't know this, is there a relationship between, that should have been highlighted, between 3 and 9 and an exponent? What is the relationship between 3 and 9 with an exponent? 3. What? 3, 3? 3 times 3 is 9. Now make that an exponent. 3 squared equals 9, yes? Now we have just been studying square roots, yes? So if 3 squared equals 9, then doesn't it follow that the square root of 9 equals 3? Everyone agrees, yes? Okay. Now, you're intelligent young people. What else on this page so far with 9 and 3 has 9 equaled 3? 9 to the 1/2 equaled 3, didn't it? Now again, you are intelligent young people. If this equals 3 and this equals 3, then what do I know about that? That they are the same thing because they both equal 3. Is everybody with me? All right. Now, next one. Let's look at this one. What is the relationship between 3 and 27? 3 times 9, which is 3 squared. So this would be 3 cubed would equal 27, correct? Just a jet. I know, I still look up when I see planes too. I'll be reffing a rugby game and a plane will fly. Oh, plane. I still do it too, and even though I'm 44. So logically, is not the cubed root of 27 3? Yes. What else do we have that relates 27 and 3 on this page? 27 to the 1/3 equals 3. So what does that tell us about the cubed root of 27 and 27 to the 1/3? They are the same. Is everybody cool? Now, without writing the next thing down, I want you just to look at it. That's the radical symbol, right? There are 3 pieces of information that I can add to that. Can I add a radicand? Yes. Can that radicand have a power? Yes, because I could find the square root of 8 squared, could I not? And can that radical have an index? Okay. So that is what a full and complete radical looks like, yes? Now, let's put in what we know from here. Where does that 9 go? B, X, or A? X. So I would have the root of 9. What power does 9 have right now? 1. So where would that 1 go? A. And what index should be right there? 2. So that should go where? Where the B is. That's what this really looks like, doesn't it? But we drop the 1 and we drop the 2 because they're automatic, yeah? But we are all aware that this is what it should look like, yes? That this should look like that, yeah? And we also know that this equals 9 to the 1/2. Does everybody see how this works? The index becomes the denominator, the power becomes the numerator. So what would it look like for every case, not specifics? What would be the base out here if I was writing this like this? What's the big thing I should write? Big X. To what power? Using this example now. You don't need to write this down yet. I just want you to think of it. What would it be? Muskan. A over B. Is everybody good? So now, that's the reason why you didn't have to waste precious brain power writing that down then. You now see why it works. So now you can write that rule. X to the A over B equals, and I like to put these 2 arrows here because it goes both ways, yes? It could be power to radical or radical to power, is the same as B over X to the A. Is everybody good? All right, now you'll notice your printing is all screwed up here, right? This B is supposed to be here, right? So I'm just going to write that in here, B 27 to the 4/3. And I'm going to pretend white out this b. And then we're going to work with these, okay? Now, when we practice, always do hard practices, right? So the game is easier. The game here is tests. This is a crazy difficult question because that is a decimal. How do I feel about decimals? I hate them. But every decimal that ends is a fraction, isn't it? So what is that as a fraction? Gersahil. 4 over 100, correct? And all of that is to what power? 3 over 2. Do we agree? Now, if it was just 4 and 3, that 3 would go everywhere, wouldn't it? Well, so now that 3 halves has to go everywhere, doesn't it? So I really have here the square root, because it's a 2 at the denominator, and that becomes the index. What does this base become? Look at my list. Where does that base go? If you don't remember the proper word, that's okay. You can just tell me where to write it. Inside the radical. The base becomes the radicand, right? And where does that numerator go? It becomes the power. Everybody cool? Now, you're intelligent young people. What's the square root of 4? 2. Hold it. I'm just going to slide this over because I'm going to get in the way of my B. The square root of 4 is 2, correct? What's the square root of 100? 10. And all of that is to what power? 3. What is 2 cubed? 8 over. What is 10 cubed? 1,000. And now I am done. Was there any new math there except for that? Was there anything new? We have added one piece of knowledge to your brains, and we proved that piece of knowledge. I didn't just tell you. You actually built this rule yourself. Gersahil.
Would we simplify the 8 over 1,000?
To what?
2 over 500 and 4 over 500.
You could. To what else?
1 over 250.
You could do that. I would be perfectly happy with that. Is this also, in my most hated version of things, 0.008? Decimals. But could I do that if I wanted to as well? Okay. Now, why did I not go further than that? Because once we get to there, is it new? No. You know how to simplify fractions. You know how to make decimals. I'm not worried about that. You brought that to this party. I am worried about what I got to bring to the party. Everybody good? All right, so let's have a look at B. Where is that 3 going to go? You got the rule right there. Where's that 3 going to go? Index. Cube root. Where's that 27 going to go? It's going to become the radicand, right? If you'll never remember that word, you don't have to. It's just what goes under the radical sign. And then all of that is to what power? 4. We know the cube root of 27 off by heart. What is it? 3 to the 4th power. We know that's 3 times 3, which is 9. And then 3 times 3 again, which is No, 3 times 3 again, which is 9. And then 9 times 9 is 81. Without a calculator, we got the answer. Everybody cool? Now, like every other thing we've done in math, can we forget any math we've ever done? When we learn something new, do we have to have math fall out of our head? No. We still all have it up in there, yes? So what is weird here? Braden. It's got 2 powers. Now, we already know, and you don't need to write this down, x squared to the 4th is what? x8. Why? Because there's 2 answers to that. One answer is because we multiply over brackets. And the other answer is because that's x squared 4 times, right? Okay. So this one's kind of yucky though, yeah? So which one of these 2 reasons is easier to work with there? The multiply or writing it all out? The multiply, of course it is. What is 1/3 times 2? 2/3. And once we get to there, doesn't it follow our rule perfectly? Where does the 3 go? Index. Then I make my radical sign. Where does the 8 go? It becomes the radicand. Where does the 2 go? It becomes the power. Do we know the cube root of 8? What is it? 2. Do we know 2 squared? 4. And I'm done. Is everybody good? The denominator becomes the index. The numerator becomes the power. Now, I'm going to show you some tricky stuff with that in a minute. But first, we're going to do some stuff that you can all handle. What is wrong with D? What makes me want to lean over? Decimal. We don't like... Oh, speaking of lean over, this morning I was stopped at a red light. This car door opens in front of me. I'm like, what the hell? She's like 5th car away, and her door is open. She's not... And there's no one else in the car. I'm like, is the driver just going to get out and abandon her car? Opens her door. All over the road. And I was like, nice. And then she closed the door, and I was like, wow, she has to be done, because that's like 20 gallons of barf on the ground. Then she opens the door. I was like, holy crap. Then the light changed. And I was like, damn, it's green and she's not driving. Am I a dink? Am I going to lean on the horn? Then she opens the door. Again. And I was like, oh. And then she drove through the light, and then she did I can't believe she did something this smart. She pulled into a gas station because obviously she couldn't keep driving. Now, most idiots in the world would continue to drive. Halfway down the road at 60 kilometers an hour, open their while they're driving. But she actually pulled off. I was going to be late for school. I almost went over to see if she was okay because she did the right thing. But I had faith. There was like 20 people at the gas station. Somebody would have helped her. I think. I hope. Now, if this were a horror movie, that was the beginning of the killer virus that's going to kill us all, right? Like, you could all see that shot. The guy, the main character, driving to work, sees the chick barf, goes over to help her out, breathes in her barf fumes, and now I'm sick? Huh? You could all see it. We could write that movie together.
Let's do it.
No, we're doing math. Nice try, though. It's almost like you fooled me. Oh, wait, I was a teenager once, too. Now, back to where I was. What's wrong with 49? 0.49. Decimal. What is it really? 49 over 100. To what power? 1/2. Where does the denominator go? It's the index. 2. Root of what? 49 over 100. To what power? You okay there, old timer? That's what my grandpa used to sound like. You're 15. Oh, this is just killing me. Oh. You do need a break. All right, what's the square root of 49? 7. What's the square root of 100? 10. That's what I want. What do you all want to do? 0.7. Would I mark this wrong? No. But would I draw a stick figure? Maybe.
What is that?
It's a stick figure barfing. Everybody else knew but you. I'm a great artist. Okay, what's weird about E? What's weird about E? G-do. It's a decimal up in the exponent. But what is 1.5 really? That's 3 over 2, right? And now we can do this in our sleep. We don't even need to think about it. Square root 16 to what power? 3. What is the square root of 16? 4 cubed is... What's 4 times 4 times 4? 64. Now, all the U's do F by yourself. Oh, 0.75. I'm so scared. What is it? Go. Don't say it out loud. It's not 1 over 4. Guy. So really don't say that out loud because that's totally wrong. Go. Really don't say that out loud because that's totally wrong.
It's 4 over 4.
Really don't say that out loud because that's totally wrong.
It's 5 over 4.
So, 81 3/4. What's next? Oh, sorry, Jade. I'll sit on my writing hand so I can't write. You'll tell me? That's badass. Okay. Oh, of course I can move the red cursor. Left-handed even. I'm going to do the rest of the question left-handed. It says 81 to the 3/4. All right, here we go. So what do I need?
You need
Index.
I need the index to be 4. To what? What is the fourth root? What is the fourth root of 81? 3. 3. To what power? 3. To get what answer? 27. That is neater than some of your people's work. Yes. If I was writing on the board, it would be even neater. You guys, who are you kidding? I know what you're doing. You want me to stop doing math, but I will get the same amount of math done. I will just go faster. So, we'll do the next one on the board. Yes. But first I will show you. Now, first of all, I tell you to use a calculator to simplify that. Don't bother. I'll show you. No. 8 to the 2 divided by 5. Do I like that?
No.
Why not?
It's a decimal.
So, we could use a calculator to do it. But we're in math class, not physics. So, that is really the 5th root of 8 squared, yes? Now, here is that thing I was telling you was going to be tricky. We've been writing it this way, yes? Right? Does 8 have a 5th root? No. What's the biggest root 8 has? 3. It's got a cube root, right? Right? Everybody cool? Okay. Here's where it gets tricky. You're allowed to move this 2 under the radical. So now I have the 5th root of 8 squared. What is 8 squared? 64. Now, 64 does have a 5th root, doesn't it? Because 64 is 2 to the 6th power. Can I get a group of 5 out of there? Yep. How many groups of 5 can I get out of there, Jade? Just the 1. So the 2 comes out here. 5th root, what did I leave under there? A 2. This is my math class answer. This is my physics class answer. Does everybody understand? Because this is what we want in math, because it's exact. In physics, you need to have a real world number, right? You would never say, move that Mars rover 2 times the cube root of 2 kilometers west, would you? No. You would say, move that Mars rover 2.297 kilometers west. Yes. Picking up what I'm putting down? Yes. Everybody with me? The real life answer and the math class answer are the same but different. Addison.
Can you explain from 5 root 64?
Yes, I will. This is what I was talking about earlier. It's the breakdown thing, yes? I can break them down in my head because I've been practicing this way longer than you. So when you see a radical, you're supposed to always break it down, right? What does 64 break into? 2 and 32, yes?
Yes.
And then 2 and 16, yes?
Yes.
And then 2 and 8, yes? And then 2 and 4, yes?
Yes.
And then 2 and 2, yes? 1, 2, 3, 4, 5, 6. So the root of 64 is the same as the 5th root of 2 to the 6th. Now I need a group of 5. I have 6. So I'm going to bring out 1, 2, because that covers the 5 I need, but that left a single 2 under there. Okay? Okay. Now sometimes it's even uglier. What do I got here? I got a decimal to a fraction. 6 over 10 to the 15 over 7. Holy crap, I don't even want to talk about it. Even in math class, if it's that hideous, what do I want you to do? Just use the calculator. Okay? If it's that hideous, I don't need you going crazy. But could we do it?
Yes.
What would this be? This would be the 7th root of 6 over 10 to the 15th power, yes? Now, where does that 15, where is it allowed to go? It could go inside, yes? So this would be the 7th root of 6 to the 15th power. Agreed? Everyone agrees?
Yes.
Over the 7th root of 10 to the 15th power. Everyone agree? Yes. How many groups of 7 can I get out of there? 2. So I could get out 6 squared, and what would stay under there? First time today, and I've said under there like 17 times. What stays there? I got out 14 sixes. There were 15, so what stays? A single 6. How many groups of 7 can I get out of 15 here? 2. So I would bring out 10 squared, and what would stay? What would stay under there? What would I write there? 10. And now I could fix this up to get 36 over 100, 7 root 6 over 7 root 10. And then you could simplify the 36 over 100 if you wanted. This is like high end of grade 11 math work. Okay? Everybody with me? But please notice, it's the exact same as this kind of easy one over here, yeah? Everybody with me? All right. So, you do not have to do anything on page 39. That's a stupid question. I don't like it. Page 40 is your homework. Page 41 is the answers. As always, you are the arbiter of your success. If you do A, B, C, D, E, F, and they're all perfect, maybe you can chill out a little, right? Do as much as you feel you need because you have the answers. There's no point in me saying you got to do all of it because you've got the answers there. But that being said, if you are finding you need more practice, then do more practice. Okay? I am not... This will take a second.